Nils, great to meet you. What is Enpal?
Enpal is in the business for sustainability and green energy, with about 80 to 85,000 systems in the field containing solar PV, batteries, wall boxes, and now also expanding into the heat pump market with about 3,000 heat pumps in the field already. Very, very fast growing.
I can imagine out there in the field, there's a lot of complex integrations with a very rapidly evolving electricity market. But from your position as a chief architect, probably also quite a lot happening, right? There's more and more devices out there. There's a lot of data coming in. What is that data? Where does it go and what do you do with it?
To make it very simple, we get a lot of data from all these products that we're offering to the customer. We have to ingest all of that, make it available for the customer to basically see what's happening at his site. How much energy do I produce? How well is my battery charged? Is my car charging right now? And also give him control over these assets, like start charging my car now, for example.
Because your proposition is evolving and because Enpal is growing quite fast, I imagine the sort of data schema needs to be quite flexible as well, right? I presume a traditional SQL database would be problematic. So how are you collecting this data and how are you storing it?
How it is currently is that we are storing incoming data in a blob storage file that is basically accumulating all of these data points for a customer per day, which is very easy to query, so the user experience is quite fast, but it makes it a bit harder to do aggregations or to prepare certain things for our customer service to have it available early. So we now are in a transformation phase where we want to take all of these data streams and make them a bit more universal and make them available to our Streamline teams, and then go with a data cooling approach to have things available in data warehouses for like aggregation and historic evaluation.
And presumably this data coming from the devices, you'd consider that time series data, would you?
That is time series data, correct.
Okay, and you are using MongoDB as a sort of hot storage database for that?
Yes, and the approach that we are now going to implement, we basically get all of these time series data, lots of timestamps, lots of sensor values, and we are transforming this into a standardized format where we basically just define how something should look like in terms of what kind of sensor are we talking about. Put all of that in our time series database to have it available for now for 30 days, but we also think about increasing this depending on the usage. And after that time, it will go into a data lake. The very positive part of this is that querying the database with MongoDB does not cost additional money. It's very easy to scope the costs, very easy to scale, and the queries are basically for free.
How much of your IT environment is in the cloud? How much of it is on premises?
That's a very good question. We do have quite a significantly sized cloud environment as Enpal as a whole, but also in the IoT department. But we also have a dedicated team for system integration, which is closer to the hardware part.
Yeah.
There is this Enpal One box that is controlling all of the hardware pieces, like the wall box, the battery, the inverter. They basically make sure that things can talk to each other, which is a way different world with Modbus over TCP or EE-bus. So we do have basically a contract between the hardware team and the cloud team so the communication can work.
How do you interconnect the two?
Currently, two methods. Well, one method is MQTT, which we onboard for newer use cases, for example, like VPP, that needs a higher frequency of data transmission. And we still have the IoT Hub, which is a Microsoft product in Azure that is connecting the more general use cases, but we want to slowly migrate away. We were on the lookout for time series databases and got in contact with at least 2 different companies of consultants. And the MongoDB consultancy was the best with quite a lot of distance to the other people. We had some very weird technical questions that you usually don't expect, because storage is one of the cost drivers, because there's just so much data.
Yeah.
We asked weird questions like, how would we expect compression to work? How does the compression algorithm go? How can we project how much data we can save by compressing our schemas? How should the schema look like? Or just simply, okay, if we do this, how big would the index be and does it fit into memory, right? Because that needs to be fast. And we got answers to all of that, actually, which impressed us quite a lot. MongoDB was very open for in-person workshops where our contacts, Andre and Philip, basically visited us on the headquarter office in Berlin. And we had a workshop together and it was great actually answering how the index is built and how it's fitting into memory. Working with MongoDB Atlas is very pleasant actually. The Terraform integration is great, so all of your projects can live as code. And the DevOps team made it very accessible for devs. So whenever you have to set up a new project, you just contribute to a repository, they review it, and if it's merged, your project is up and running in like 10 to 15 minutes. That's very pleasant because it makes testing out things very, very easy. On the service part, whenever you need something, you can either configure this through this repository offered by the DevOps teams, or you can just go through Atlas and try things out. For example, if you want to just play around a bit, you can open a playground cluster, load the sample data set, which is available, and then, for example, try out Atlas Search to see how it behaves for you. And sharding in general is a pain, usually. It's very easy with MongoDB. For the schema, finding a schema that works can be very challenging, but MongoDB is always very open to do design reviews. So if you have questions or if you are in doubt that your schema is fine, you can always hook them in, basically explain your use case, show the schema, and get something out of it, like an improved schema or like a way forward at least.
That sounds genuinely really helpful.
That is very helpful, especially if your team still has to grow skills in the particular technology.